Hello there, my fellow interneter. Um, it is quite exciting to be making the first video of this channel, but the problem is I don't have any good topic to talk about. But I do have a project that I'm currently working on, and I'd like to talk to you uh, about the part of that project. So this is what I wanted to show. What I'm going to show you in this video is how I got MQTT working on ESP32 without any libraries. Um, I'd like to tell you, I'd like to warn you that this video is not a tutorial. This is basically just, I don't really have any good topic to talk about for the first video, but I'm currently working on this project. So I think it might be interesting to actually talk about this. This is not a tutorial. I think I might have done a lot of things wrong here, um, but I'd like to talk about it. So what I'm going to show you is how I get MQTT to work on ESP32. But before we get into that, I'd like to tell you a bunch of things about the Arduino framework for ESP32. So one of the interesting thing about the Arduino framework inside of ESP32 is that the framework itself is actually built on top of the ESP-IDF framework. So when you're coding in Arduino when you're coding ESP32 in Arduino, you're technically using ESP-IDF. And because of the Arduino framework for ESP32 is built on top of the ESP-IDF, you can actually use some of the libraries inside of the ESP-IDF. Well, there's a catch that from my experience using the library on the Arduino version of the library, it's actually it's not significantly different, but there are differences between the Arduino version and the ESP-IDF version. It's not really significant, but I will show you how I managed to move the but but I would like to show you later on how I managed to find out the differences between the ESP-IDF and the Arduino, so that I can write some ESP-IDF code in Arduino. Yeah. So anyway, I'm not really a native English speaker, so I'm struggling on constructing sentences in my mind. Most of it is just based on gut feeling and vibes. I really should start to learn English grammar properly. I do have a plan for that. Well, not really. If you have if you have some free resources on English grammar, if you would like to share it, I will. I appreciate it. Thank you. So where was I? Oh yeah, different system. Okay. So I'm going to show you how I managed to overcome the differences. And the next thing that is worth mentioning is that because the ESP32 is actually running, so ESP-IDF itself is it's running on top of an operating system. You're not writing bare metal code to the ESP32. You're actually writing code on top of a operating system. To be more specific, it's a real-time operating system, and it actually behaves like operating systems. It has networking stuff already built into the operating system, so all you have to do is just activate it and use it. And the next thing that is worth mentioning is that you can write code asynchronously. That means you can have two functions, two while loops running at the same time. Usually the Arduino, usually the tricks is using millis, but ESP32 already has, the RTOS already supported running multiple tasks concurrently. So yeah, it's worth mentioning. So I'm going to get into it, but before getting to the MQTT code, we're going to get into the Wi-Fi code, and show you how I activate Wi-Fi on ESP32. So this is to the left. So this is the Wi-Fi code, and again, this is not really a tutorial. I honestly, I honestly do not understand, barely understand some of the stuff inside of this code. I'm sorry. Yeah, it's pretty loud outside. So yeah, again, I barely understand what is actually being written inside of the function. I'm just taking the example from USB IDF and then I copied that over to the Arduino sketch. So yeah, this is the Wi-Fi. So this is the part where the Wi-Fi starts. So the first thing that you do is, so I'm just going to show you the important parts, the parts that I kind of understand. Just take it as a grain of salt. So yeah, the first important thing is to initialize the network interface. I think this is initialize the network interface inside of the RTOS. Apparently the RTOS can also support Ethernet. Yeah, it's not just Wi-Fi, it can also support Ethernet. So yeah, you're gonna have to initialize the network interface in the ESP32, in the RTOS, I don't know which one. And the next thing is to create the Wi-Fi station. That's what this code actually does. So let's create the Wi-Fi station and initializes the Wi-Fi with default configuration. And this part of the code, I'm going to talk about this later, but in a nutshell, what this part of the code does is that it's you are registering some events to a function. So if the Wi-Fi starts, what function should be run? If the Wi-Fi got disconnected, what function should run? Well, more like handler, not really a function. If it's connected and then gets an IP address, what handler should it run? So this is what the code, this part of the code does. And then below that is the Wi-Fi configuration, where you store the Wi-Fi name and the password. So yeah, this is a struct called. So I named the struct Wi-Fi config, and just using string length copy to copy the SSID to the struct. I don't know if this is a good way to do it. Yeah, I just do it that way. And below that, there is the there's more Wi-Fi configuration. So you set the Wi-Fi mode to station, and then you set the configuration to the configuration that to this configuration that has been written earlier, that I've mentioned earlier. And this part of the code is quite interesting. It's not really necessary. I don't really know, but it's not really included in the documentation and on the example. I'm sorry, it's not really included in the example. But I was having Wi-Fi issue. And I just copied this whole code to ChatGPT, and then it mentions that about power save mode for the Wi-Fi. And what this code basically does, it turns off the power save mode for the Wi-Fi, and it actually kind of makes the Wi-Fi a bit more well, not a bit more, kind of make it more reliable. And yeah, I also encountered a bunch of problems when starting the Wi-Fi. So perhaps I need to let the Wi-Fi to settle, the Wi-Fi stuff to settle, as mentioned in this comment right here. Just wait 2 seconds. Just wait for the Wi-Fi stuff to settle, and then I start the Wi-Fi. And yeah, that's how the Wi-Fi is being started. About the event handler, where some where some events will be followed by a handler, and if some event happen, then this handler will be run. Uh, so so the code about these 3 lines, this code. So these code lines over here, it's an instance. So it's a I don't really understand why it needs this. I don't really understand what this is, but you have to declare the handler instance, and down here this is where you register the event to the specific handler. So for example, this is the Wi-Fi event, and then this is Wi-Fi event start. So this is where the Wi-Fi this is where the Wi-Fi starts. So when the ESP Wi-Fi starts being turned on, this event will occur. Then if this event occurs, then it's going to start the start handler, which is here. So this is the start handler. And inside of this handler is basically a function, but it's called a handler. So inside the handler, there's going to be the Wi-Fi connect code. Just for do not mind the semaphore. And this is what matters. So yeah, this is where the Wi-Fi is going to connect. So it's going to start looking for the access point, and then it's going to connect it. If it cannot connect it, it's going to start the disconnected event. So it's going to go to the Wi-Fi event station disconnected. So if this event occurs, then it's going to obviously run the disconnect handler, and this is the disconnect handler. It's quite interesting, the disconnect handler. What I did here is I use a timer. So when the Wi-Fi disconnects, it's going to start a timer for a set amount of time, for example 30 seconds. So it's going to wait for 30 seconds to run this callback over here. And the callback is basically the same as the start handler, which is connect to Wi-Fi. So it's basically what this, in a nutshell, what this part of the code does is start Wi-Fi 30 seconds later. So it starts Wi-Fi every 30 seconds. And after a certain amount of attempts, so if it hits, if I set it to, I wanted the max retry to 5, it's just going to connect 5 times, and after that, it's not going to connect anymore. So yeah, if it's connect more than the max retry that is being configured, so if it connects more than the amount of time that it's configured, then it's going to basically just stop connecting and just being stuck. I accidentally made the Wi-Fi code in a way that it has to connect to Wi-Fi first in order for the other things to work. Okay, that's the disconnect handler, and the IP event handler. This is where this event occurs when you get the Wi-Fi, when you connected to the Wi-Fi and got an IP address back from the router, and this event will occur, and this handler will be run. The audio kind of glitched out in that part of the recordings. Going to record it back. I was explaining the error handler. Well, not me. Okay, I was explaining the Wi-Fi one. Just gonna close this window. So yeah, so when this IP event occurs, which means again, you get IP address back from the router, then it's going to run this IP handler, and inside of the IP handler, it's quite obvious, it's going to print the IP address. And what this part of the code does is not it's not really necessary for me to explain, but I wrote the code in a way that this I wrote the code in a way that anything will not going to happen until it's going to get an IP. So if it gets an IP, what this code is going to do is going to signal the setup function to continue doing. So it's going to signal this function to execute the MQTT client. And if it's not receiving the signal, then it's going to block there forever. So if the Wi-Fi never connects, then the whole thing will never start. So yeah, that's the Wi-Fi code. And let's move on to the MQTT code. So for the MQTT code, let's talk about the MQTT app start first. Whoops, what did I just click? So yeah, let's start with the MQTT start function. So here it's basically a configuration on like, okay, what's the MQTT broker, what's the username, what's the username and password. And also here is a last will testament, which means if the ESP32 is somehow disconnected from Wi-Fi, the server is going to know that okay, after 30 seconds and after the keep alive, the server is going to ping. I assume that's pinging to the ESP32 every 30 seconds to check whether the ESP32 is still alive or not. And if it's not, it's going to send a message to this topic right here that's going to mention that, oh yeah, the ESP32 is offline. So this is the MQTT code, and yeah, it's just basically configuration. Yeah, this is the configuration part of the code, and this is the part where you register some of the events to the handler. So for example, the event connected. So I'm just going to explain this. So this will register the event connected to the MQTT connect handler, which is right here. So when it connected to the server, it's going to publish to the server that it is online, and the next thing it's going to do is subscribe to a certain MQTT topic. And the next event is the MQTT event disconnected. When this event occurs, it's going to run the disconnected handler. It just prints disconnected. Oh, I forgot to use the error handler. I forgot what the name of the error event is. But anyway, and the event data. Moving on. Moving on is the not really feeling too well at the moment. So the next thing is the event, the data event. So when data comes in, this is the handler that is going to be running. So when data comes in, you can retrieve the topic and also the message, the payload of the MQTT payload. And the last thing is just start the MQTT client. So that's the code part. Let me demonstrate to you how this works. So I'm going to plug my ESP32. I'm just going to show you the demo of this of the code that I've shown you earlier. So I'm going to connect my ESP32, and there you go. It's going to connect to Wi-Fi. There you go. So it is connected to the MQTT client. It's connected to the MQTT broker, and it has already subscribed to the topics. So this is basically test topic. I'm just trying to get MQTT to work on ESP32. So yeah, this is the QoS topic. I don't know what QoS stands for, but yeah, what it basically does, it's like it tells whether the ESP32 is offline or online. And the thing about the last word, the LWT from earlier. Yeah, so this is the purpose of the LWT. So if the ESP32 got disconnected from Wi-Fi and the server cannot ping back to the ESP32, the server is going to automatically send the offline packet, the offline message to this topic. So that's really how you know whether the ESP32 is online or not. And so yeah, that's so yeah, it also it's basically publishing. It's basically publishing to the topic. So yeah, if you wanted to know how it published, this is the function that you run if you wanted to publish a message to the MQTT broker to a certain topic. That's how you do it. This is the function that you use, the ESP MQTT Client publish, and to receive the data. So that's basically publishing and QoS and Laswell Testament. Yeah, it's I don't know what testament actually means. So yeah, that's the publishing code and the Laswell Testament stuff. And yeah, the next thing I'm going to show you is how it's going to receive data. So it's going to be handled. So when it receives data, again, this handler is going to run, and it's going to print out the topic and the data. So let me demonstrate that to you. There you go. So that's topic. So that's the topic. ESP get basically matches the topic over here, and then the data is hello. So I can send this multiple times. Yeah, one other thing I forgot. One thing that I wanted to show you. So I told you that I'm going to show you how I managed to overcome the differences. The differences between the ESP-IDF libraries and the Arduino version of that ESP-IDF libraries. So, okay, I encounter a problem, and that problem is that so this is the Arduino ESP32, right? When I try to search for MQTT Client.h, it is not showing up. So what I usually do is I highly recommend you to use Platform IO instead of the Arduino IDE. I'm using the Platform IO CLI. There's also the VS Code version of it. I'm sorry, I'm quite lazy to make tutorials for that. But the way that I overcome the differences is by okay, first of all I need to open. So what I did is I go to this particular folder. I think it's the SDK. I think it's the SDK because it does, because it is inside of the SDK folder. I'm currently using ESP32S2. I don't think it matters. Yeah, I recommend you to use the particular, for the folder. I recommend you to use the particular, like if you're using the ESP32, look for the ESP32 folder. If you're using the S3, look for the S3, and so on. I'm currently using the ESP32S2 chip, so I'm just going to use that folder inside of the SDK folder, and I'm going to go to include, and this is where the libraries live. Well, not really the libraries, but the header file, I think. Yes, I only manage the header files in here. So for example, let's go to the Wi-Fi. Where is it? ESP Wi-Fi. Yeah, let's go to that. Let's go. Yeah, let's have a look at the ESP Wi-Fi header file. And so bear in mind, this is the Arduino version of that ESP IDF libraries because, oops. Because yeah, as you can see, it's the firmware Arduino ESP32. So this is the Arduino version of that library. And I will show you and on the next I'm going to open up another pane here that is going to be the example code from the ESP IDF, not from the ESP IDF Arduino, but the OG ESP IDF. So here you got the Wi-Fi configuration, right? Okay, it's actually where's the MQTT? There you go. So to the left is the what is it? Is the header file from the Arduino version of the ESP IDF, and to the right is the example from the OG ESP IDF. So here in the example, if you scroll down to the configuration, so the .broker address URI, for example, it's actually not. It is not called. It's actually do not. Yeah, it's actually well. It's not called the .broker.address.uri. It's not called. This is not where the .uri member is is living at. Yeah, that's not where the URI. Like in the OG ESP-IDF, yes, this is where the this is where you write the URI. This is where the URI member live. But in the Arduino version, hold on. I could just there you go. Yeah. In the Arduino version, you don't have to go to the broker struct and then you have to go to that. You don't have to do this. You can just have a look into this, and as you can see, all you have to if you wanted to write the Arduino version, all you have to do is just delete this because this is the struct. So yeah, I cannot really find the official I cannot really find the official documentation website. This is the header file is what I use for documentation because, and it also explains some of the things. This is the MQTT broker URI, and this is the MQTT server port if you're using the host, I suppose. This is the client ID. Yeah, it's basically like that. Yeah, that's it. Yeah, as you can tell, there's a difference. In the Arduino version, if you wanted to include the URI, all you have to do is just call this URI member. But on the ESP IDF version, you have to go through the broker struct, and then you have to go through the address struct, and then from there you can access the URI. So yeah, that's basically how I managed to overcome the differences between the ESP IDF, the OG one, and the Arduino version one. Yeah. So yeah, that's it. I'm really sorry. The first video is kind of messy, but yeah, I hope you enjoy it. Yeah, I'm just making this video is also a way for me to basically improve my English, because I don't really talk. I have met a bunch of native English people that native native English people sounds weird. I do talk to people to people that actually speaks English natively. Or not people, person to be exact. Well, yeah, people. I don't really have that much fun, honestly. So yeah, thanks for listening and watching this video. It's kind of a boring video, I know. So yeah, that's it. Yeah, thank you for watching, and I will see you in the next video. Goodbye.